We are coming up on our third lesson from section 11.1, where we're going to look to solve a quadratic equation now by completing the square. This is a process that involves a lot of the work that we've done in the previous two videos, but it's going to add a few additional steps in the beginning. And you'll see here that I tell you to start by calling a cap. So what do I mean by this? Now, these aren't usually written in these capital letters, but when you have a quadratic equation written in the form of ax squared plus bx plus c equal to some value, could be, we'll just say it's equal to 0 for the moment. When I have it written this way, we need to work with the a, the b, and the c in the beginning of this to kind of set this up. So you'll notice that I have a cap here because what we're going to do is kind of work in this order. So we're going to basically do the following here for the first step. We're going to isolate C. On one side of the equation. So we isolate the value of C on one side of the equation. It may start off that way, and if it is, great, you don't have to do any work. But if it's not, then we need to make sure that that does in fact happen. So the second step that's going to be involved here is to divide equation by a if needed. In the first few problems we're going to do, we're not going to be saddled with that, but it will come up in later problems, and you can expect that on my test you'll certainly get at least one question where you're going to have to divide by a in the process of being able to complete the square. And then 3, and this is where we kind of begin the work of doing what we were just doing a little while ago. We take the b, divide it by 2, and then we take the b that's divided by 2, that's a b, and we square it. So we first work with c to isolate it on one side of the equation. We divide the equation by a if it's needed, if the value of a is not 1. And for the last part, we take b, we divide it by 2, and then we take that value of b divided by 2 and then square it. After this, I kind of need to walk you through the process from there. At that point, most of the work is going to begin to look familiar to you. So let's go ahead. Keep these notes handy for yourself. Keep these notes handy for yourself. I recommend, leave these on a separate page so that you can consider these as we work through the problems. I also recommend keeping this area blank, as you may want to make additional notes for yourself as needed to help you walk through this process. So I'm going to recommend keeping this part blank for yourself and put additional notes as needed. And we're going to begin to take a look at solving problems through the process of completing the square. So let's take a look now first at 58. So here we have x squared plus 8x is equal to 9. So first thing we want to look at is, how do I identify what a, b, and c is? Well, the number a is always going to be the coefficient, or the number that's next to the x squared term. In this case, that number is going to be 1. The value of b is always going to be the value that's next to the x term, or the variable that is by itself with no exponent. So here that's going to be positive 8. We identify the c term. I like to often think of the c term as the constant that doesn't have a variable in a quadratic equation written in this form. So as we look at this, we can kind of see, if we're calling a cab, that the c term is isolated on one side of the quadratic equation, so we don't need to do any work to isolate it. So that addresses the problem with step 1. And that won't always be that way, but for this problem it is. Next, when we take a look at the value of a, we see that the value of a is 1. So dividing by 1 isn't going to change the problem, so we don't have to worry about a. At this point now, let's see how we can do the work with b to begin solving this equation. So here's what we're going to do, and here's going to be the little addition now. I'm going to go ahead and take the value of b, which is equal to 8, and I'm going to take 8 and divide that by 2, to get the value of 4. I'm going to star this, just like I did in the last problem. Once I take the 4, I square this value, and I get 16. So now what I'm going to do with this 16 is I'm going to go ahead and add 16 to both sides. And I'm going to do it exactly like this. X squared plus 8x plus 16 equals 9 plus 16. So notice here, I'm not throwing it underneath and then getting a result. I'm just putting it in exactly like this. Now, what you should notice over here is that 9 plus 16, well, that's 25. At this point, because of the work we've done here, and I think we may have done it with actually this or a very similar problem, is I want to see if I can rewrite this as a perfect square. And sure enough, I can factor this as x plus 4 plus 4. This is why we do this work on the side to generate this number. And in fact, if you want to know what number is going to go here, you look for the number we star in the first step of what we do with b. So I can take x plus 4 times x plus 4, and I can write this as x plus 4 squared equals 25. So now this work should begin to look a little more familiar with what we were doing. Again, what am I trying to do? I'm trying to solve for x. So next, I need to take the square root of both sides, and that's going to produce for me x plus 4 is equal to plus or minus 5. Again, that work should look familiar with what we saw in the previous videos from section 11.1. And the last part I'm going to do to get x by itself is going to be to subtract 4 from both sides. That's going to give me x is equal to negative 4 plus or minus 5. Now, sometimes they may ask for a solution written this way, but most likely, especially when it's just numbers involved, you'll be required to give 2 actual solutions, which you can obtain by writing negative 4 plus 5, then negative 4 minus 5. And that's going to give you here, negative 4 plus 5 will be 1. Here, negative 4 minus 5 will be negative 9. And these are going to be our 2 solutions for this quadratic equation. And this is the method called completing the square. Let's go ahead and take a look at some more of these questions. I'll make sure to walk through at least about 4 of these, so maybe 3 more problems that are like this. And then we'll take into a few questions that are a little more challenging in the sense that we're going to have to divide through by a or work with fractions, things of that nature. So let's go ahead and take a look at question 62. So here we have x squared plus 16x plus 15 equals 0. So in this problem again, we're calling a CAB. We want to isolate the value of c on the opposite side. The value of a is 1. The value of b is 16. The value of c is equal to 15. So I'm going to subtract 15 from both sides to get x squared plus 16x equals negative 15. So as I'm doing this work, I realize, let's see, I have the c isolated. Next, I look for a. The value of a is equal to 1, so I have nothing to divide through. That's done. Now I can address the value of b, which is equal to 16 for this problem. So since b is equal to 16, I can take the value of 16, divide that by 2, and that's going to give me 8. I'm going to star that. Now I'm going to jump to this step more directly this time. So, or at least I go to this a little more directly, and I kind of show you how to shortcut to this. Now, once I take the value of 8, I'm going to square that, and I'm going to get 64. So the number I get as a result of taking the b term, dividing it by 2, and then squaring it, this is the number I'm going to add to both sides of the equation. So now I'm going to write this as x squared plus 16x plus 64 is equal to negative 15 plus 64. Well, if I look at this here, maybe you have a hard time trying to factor these. I see I have a positive 8 here. Okay, so since I know that's a positive 8 here, I can write this as x plus 8 times x plus 8. Please feel free to check yourself that 8 times 8 is in fact equal to 64, and that x plus 8 equals 16. It should work out. That's why we do this procedure. And then this other side is going to simplify to 49. I can simplify this side now as x plus 8, the quantity squared, equals 49. And then from that point, I can go ahead and take the square root of both sides to get x plus 8 equals plus or minus 7. From here, I need to solve for x. I'm going to go ahead and subtract 8 from both sides. And that's going to yield for me x equals negative 8 plus or minus 7. So again, if I want both solutions, I'm going to partition this off, taking negative 8 plus 7, and then negative 8 minus 7, so that I have x equals negative 1, and here I'll have x equals negative 15. Watch your subtraction and addition of integers. Be careful of that. Sign errors are common, especially when first learning this because of the complicatedness of the procedure. So that's the next problem done here. Answers that are pretty straightforward and simple. However, they don't always work out quite this neatly. Let's go ahead and take a look at 64 next. So in 64, we have t squared plus 6t minus 5 is equal to 0. So remember the CAB rule. I identify the value of a being equal to 1, the value of b being equal to 6, and the value of c being equal to negative 5. Now they're not always going to be written for you like perfectly this way, so one should be prepared for these possibly looking a little different. Okay, so I may change these up. But let me get the c by itself by adding 5 to both sides. So it'll be t squared plus 6t equals 5. So I've moved the c and isolated it to one side of the equation. I identify that a is equal to 1, so I don't need to change anything about that. So now I've taken care of c, I've taken care of e. Let me address b now. Since b is equal to 6, I take 6, divide that by 2 to get 3. Start with that. Then I take 3 and I square it to get 9. So I'm going to add 9 to both sides now. So it's going to be t squared plus 6t plus 9 equals 5 plus 9. I see I have a plus 3 here, so I'm going to write this as t plus 3 times t plus 3. That 3 gives me what goes here. That's going to be 14. Now I can write this as t plus 3 squared is equal to 14. When I get to this point, I'm going to do what I've done. I'm going to go ahead and take the square root of both sides and write this as t plus 3 is equal to plus and minus radical 14. So you'll notice here that we're getting something over here that doesn't simplify too nicely. We did get an imaginary number on one or two of our problems that we did in earlier videos. So at this point here, I want to solve for the value of t. So I'm going to subtract 3 from both sides. So the value of t is going to be equal to negative 3 plus or minus radical 14. So this is one way to write the solution. Another way to write this would be to separate this out as t equaling negative 3 plus radical 14, and then t equaling negative 3 minus radical 14. So you may be asked to write the solution this way. You may be asked to write it as two separate solutions. Just depends whatever the question is asking you and what you're asked to do in MyMathLab. So these are some basic type questions. Let's begin to take a look at some questions to continue working on completing the square. So one concept we talk about here when we're talking about a function in this case. So let's say we're given a problem like 66. The directions of this, you're being asked to complete the square, to find the x-intercepts. Given by an equation. That's listed. So, when we graph a quadratic function, most quadratic functions are going to cross once or twice on the x-axis. So now this is something that may look very unfamiliar to you, But long story short is we will go over this in greater detail in the later part of this book. Okay, so at these points where we have x and y, another way we can describe this is as x and f of x. When you're asked to do these type of questions, there's only going to be a few. What we're really saying is that at these points, this may be the point 1, 0, this may be the point 4, 0, but the value of f of x is going to be 0. So when you see a couple of these questions appear in your homework, all they're asking you to do is to set the original problem you have to set that equal to 0. That's all they're looking for in this. So let's take a look at the problem with 66. And this says f of x is equal to x squared plus 6x plus 7. Now, what I'm going to tell you is I'm one of those that prefers to have everything to the left. So I'm going to go ahead and just rewrite this problem as x squared plus 6x plus 7 equals f of x. So as I mentioned, if we want to see where this crosses the x-axis, or what the x-intercept is, we're just going to let f of x be equal to 0. Key point here, because if you leave this in the equation, it's going to be a mess. So x squared plus 6x plus 7 equals 0. Once we just establish that, and now all the rest of the work here is the same. So let's begin to do this now. So I'm going to subtract 7 from both sides to isolate the value of c. To get x squared plus 6x equals negative 7. The value of a is still 1 here, but that's not going to be the case with the next question that we do. We're going to kick up the difficulty a little bit. A is 1. Now for the value of b, that's going to be equal to 6. So we take 6 divided by 2 to equal 3. I'll star that. And then 3 squared is going to equal 9. So I'm going to add 9 to both sides. X squared plus 6x plus 9 equals negative 7 plus 9. And right now, I'm going to jump directly to this. I know that this is going to be x plus 3 times x plus 3, so I'm going to write this as x plus 3 squared equals 2. So I skipped a step there. Why? Because I'm trying to conserve space. I'm almost out. So at this point, if I take the square root of both sides, I can write this as x plus 3 equals plus or minus radical 2. If I subtract 3, move this up a little bit, then x is going to equal negative 3 plus or minus radical 2. Or if I split this up, I can write this as x equals minus 3 plus radical 2, or x equals minus 3 minus radical 2. So now I really didn't skip that step because I was running out of space. But if you go from this to this, you can skip that step because the work we did over here kind of just breaks it down nicely, but hopefully you should get to the point where you can go right from here to here because of the work we do in the first step of dividing b by 2. Okay, so we're going to do a few more of these questions before we call this lesson wrapped up. So we're going to continue on 11.1 with a few more rich questions. Let's take a look now at 72. So 2 more questions. Make sure you can see all this. Okay, so 72 is going to be 4x squared plus 8x equals negative 3. So in this question, the value of c is on the other side, is isolated from the rest of the quadratic equation. But here we have a value of a that is not 1. So we need to divide everything by the value of a, which is 4. So we divide this by 4. We divide this by 4, and we divide this by 4. So fractions are going to become an integral part of the problem, and we need to be careful working with them. When we divide everything by 4, we're going to get x squared plus 2x equals negative 3 over 4. Please leave it as a fraction. Don't try to mess with it beyond that. Well, we've isolated c. We divided by a now. Now we need to take the value of b, which is equal to 2. We need to square that, so we're going to, we need to take 2 divided by 2 to get 1. Then 1 squared is going to equal 1. I'm going to go ahead and add 1 to both sides. So I'm going to write this as x squared plus 2x plus 1 equals negative 3/4 plus 1. So hopefully we can kind of cut to the chase here. And since I know that this is, I got 1 in the first step here, this will be x plus 1 squared. Well, negative 3/4 plus 1, if you need to, do the work over here. So if we have negative 3/4, well, plus 1 is like plus 4/4. Negative 3 plus 4, that's going to be just plus 1/4. So we're just going to write x plus 1 squared equals 1/4. That's it. If we take the square root of both sides, then we're going to get x plus 1 equals plus or minus. Well, the square root of 1 is 1. The square root of 4 is 2. So it's just plus or minus 1/2. So not a terribly difficult fraction to work with, a lot better than some of the other ones you may see. If I subtract 1, then I'm going to get x is equal to negative 1 plus or minus 1/2, which can simplify to negative 1 plus 1/2, or negative 1 minus 1/2. Well, negative 1 plus 1/2, you can write this as negative 2/2 plus 1/2. X will equal negative 1/2. Here you write this as negative 2/2 minus 1/2, and x will equal negative 3/2. And these are the two answers for question 72. So what happens in some of the more difficult problems is that you may not only have an odd number for b, but you may have a fraction for b, as I alluded to a little earlier. So let's take a look at one such problem before we wrap up our lesson for the day in 11.1. Let's take a look now at question 74. So 74 is going to be 2x squared minus 5x minus 3, and that'll equal 0. So in this question, we have to do everything in this question. So the answer itself isn't particularly terrible, but we have everything to do. We have to get c by itself on the other side. So I'm going to go ahead and add 3 to this to get 2x squared minus 5x is equal to c. We also have to now divide by a. So I'm going to divide by 2, divide by 2, divide by 2. And you notice here we're going to get x squared minus 5/2x equals 3/2. And finally, I need to take the value of negative 5/2, and I need to divide this by 2 and then square it. So I know b is equal to negative 5/2. But remember, when I have a fraction, instead of dividing by 2, I just simply multiply it by 1/2. So I'm going to get negative 5/4. Star that because it's going to be really important for finding our factors later. So if I take negative 5/4 and I square it, that's going to give me positive 25/16. So I'm going to get 25/16 here. I'm going to add 25/16 to both sides. So I'm going to kind of cut to the chase with this here. And I'm going to write the factor right from this here. Actually, no, let me write this out. It'll be x squared minus 5/2 plus 25/16 equaling 3/2 plus 25/16. Instead of trying to do all the factoring here, I'm going to take the negative 5/4 and put it right in. If you have a difficult time seeing this because of the fractions, take a look at previous examples where I do that. But now we have the question of 3/2 plus 25/16. So if we're going to add these, we need to have a common denominator, which means I need to take 3/2. So let's do this kind of up here. If 3/2 plus 25/16, I need to multiply this by 8. So that's going to be 24/16 plus 25/16, which is going to give me 49/16. So now I have this. I'm going to write this as x minus 5/4 squared equals 49/16. And now I would suggest writing this down twice. I'm running out of room, so I'm not going to do it, but write this down a second time. and then take the square root. And that'll give me x minus 5 over 4 equals plus or minus 7 over 4. So the fractions are not pretty, but they're not unbearable. I'm going to add 5/4 to both sides. So this is going to be 5 over 4 minus, or plus and minus, 7 over 4. So that means the values of x, let me kind of put this work here now. X will equal 5 over 4 plus 7 over 4. Then x will equal 5 over 4 minus 7 over 4. 5 plus 7 is going to be 12 over 4, which will be equal to 3. 5 minus 7 is going to be negative 2 over 4, or negative 1/2. So x is equal to 3, and x is equal to negative 1/2. So those are our two answers for those problems. And that pretty much wraps up the kind of work that we're going to do in section 11.1.